This time we're going to talk about the different propositional forms. So what are propositional forms? They are sequences of symbols that are made up of our sentence letters, which are our propositional variables, and our logical operators. And here are some of our basic logical operators: and, or, not, the conditional, and the biconditional. So these are the symbols that we need to be mindful of when we're going to talk about the following logical operators. Now, for each propositional form, a truth table will be constructed to see the truth values for each of these said forms. So let's look at the following propositional forms. The first one is the negation of P. So usually it is read as not P, written in the following ways, using this one, or this one, or this one. So for example, let's say P, a square has exactly 4 sides. So if we're going to have not P, that would mean a square does not have exactly 4 sides. So that is how we do the propositional form, the negation of P. So given the truth table, if P is true, then it would mean rather that not P would be obviously false. And if P is false, then not P or not false would be true. So that would mean that the truth value of a said proposition will be the reverse of it when we get the negation of it. Because anyway, there are only two truth values, true, false. The next propositional form is the conjunction of P and Q. So this is usually read as P and Q. So we have this way of writing P and Q. So for example, let P be the statement pi is a real number, and let Q be the statement pi is also a constant. Therefore, we can say that P and Q is pi is a real number and pi is a constant. But because we're using the English language, we can simplify the statement further by saying pi is a real number and is a constant. So, if we're going to construct the truth table for the conjunction P and Q, we have to take note that the word and implies that it has to consider both of the propositions. So, in this case, of course, if both of them are true, then it would be a true statement. However, since if we would have false statements, so we would say if P is true and Q is false, then that will give us a false statement. Similarly, if P is a false statement and Q is a true statement, then it will still give us a false proposition. And if both propositions are false, then it will just be a false proposition for the conjunction as well. So as we can see, the conjunction will only be true if both statements are true. Otherwise, the rest would be false. Next up, we have the propositional form, the disjunction of P and Q, which is usually read as P or Q, symbolized in this way. Say for example, we have the propositional P cosine squared x is equal to sine squared x minus 1. Proposition Q, 5 negative 2 is in the fourth quadrant. So if we would have the proposition P or Q, that would mean cosine squared x is equal to sine squared x minus 1, or 5 negative 2 is in the fourth quadrant. So that is an example of our disjunction of P and Q. We will use the word or. And since we are using the word or, that means it can either be P or Q that we consider. So if we have a false or true statement, that would be true. Because anyway, we need to consider just one. If we have a true or false statement, then we would still have a true statement. If we would have both true, obviously we would have a true statement. However, if we would have a false statement, then that's the time it would be false. So, As we can see here, for disjunction, all of its statements are true unless both statements will now be false. So that is disjunction. Now let's go to the conditional statement. It is also known as implication, and it is read as if P, then, let's just write that, it was missing an N, if P, then Q, and is symbolized this way, if P, then Q. Another way of reading this would be P, let's write it down here, P implies Q. So that's another way of saying this statement, if P then Q. This can also be read as P implies Q. So, say for example, we have the statement angles are vertical, and Q would be angles are congruent, and if we will now combine them in the propositional form P implies Q, we would have if angles are vertical, then they are congruent, or angles are vertical implies that they are congruent. Now, when we talk about the truth table of a conditional statement, this is how it would be. If both statements are true, then that is considered true. However, if P is true, but then Q is false, then the conditional statement would be false. Now, if the first statement P, false, implies something that is true, that is still true. While if something false implies something false, that would still be true. So the only time that a conditional statement, an implication, will be false is that if something true implies something false. It's the only time that it will become false. Now, there are other forms that make up the conditional statement, and they also have certain conditions within their truth values, and we're going to look at some special forms of the conditional statement and the last propositional form in the next video.